So let me give a little bit of background on what this talk is really for, and then also why it's worth doing. In 2017, I think it would have been, I started my second proper year at UNL. And actually, no, it might have been 2016. I think I might have done this right when I showed up. But the long and short of it is I showed up as a freshman. And some of my classes weren't going as quickly as I would have liked. And the other thing is, every student I've ever met who really enjoys learning, they want to go and they want to do cool stuff, right? Even if they're not necessarily ready for it, right? You chuck them in the deep end and they swim. And so I saw through bits and bytes that the Holland Computing Center was doing their annual fall Kickstart. And they, had this cool blurb and it said, learn to use a supercomputer and gain access. And I went, that sounds pretty cool. I'd do that. And so I played hooky and I skipped class for 2 days. They gave me free lunch. They stopped doing that probably because of people like me, but they gave me free lunch. And so I went and I sat there, and my goal when I walked in was that I wanted to try running some kind of basic machine learning hello world during the course of this seminar, and then run it on the university supercomputer. Because when you're trying to train any kind of neural network, you need a lot of compute resources and it gets expensive. Or you can run it on your gaming PC and it'll just run for 2 weeks instead of 20 minutes. So point being, I was able to pick this up without that much prior experience. All you really need is I would call it a very rudimentary grasp of the Linux command line. You need to know how to SSH onto the machines or where to access the different devices. You need to know how to actually allocate a job. And once you've got that done, you can take and run whatever you want without too much work. And when I say that there's a lot, I'm not doing it justice. There are huge bodies of existing code and tools and just toys waiting. And all you have to do is pick it up and twist the handle. And recently I learned about stable diffusion. Did anybody else see this? Yeah, I see Aaron nodding. So I can't really hear you guys. So if you want to chime in, like maybe drop something in the Zoom chat or something like that. But yeah, so one of my goals when I have 10 minutes to breathe is to go and try and run it on HTC, just because I think it'll run faster than it will on my local computer. I have no idea whether or not it's doable, but it's worth trying. So point being, to go back to the story, what happened was after the Kickstart, the way that they did it, they gave us YubiKey access. So they handed everybody at the Kickstart a YubiKey. And that was what gave you access to the supercomputer. And you used a guest account. And that guest account then allowed you to log in and run jobs. The problem was that if you were not part of a research group whose PI already had an account with the Holland Computing Center, there was no pathway for students to get access to these compute resources. And as a result of that, for probably about a year or so, until I actually took a class that was specifically on grid computing, CSC 435. The folks who run that are really awesome. If you get the chance, they offer it like every other year. You set up your own cluster on Raspberry Pis. It's really cool. I highly recommend it. But until then, I didn't have a valid excuse to get an HTC account. And once I did, I was fine. But now OS2G has their own HTC user group. And the process for getting such an account is incredibly straightforward. There's a form on their website. You put in like 5 details. They send you an email. You go down to their office. You confirm that you're you. They add you to Duo, and congratulations. You now have access to a very, very large amount of CPU resources. So with that out of the way, I'm going to share my screen if this works. We'll see what happens, but I'm optimistic. So what we're going to do is we're going to hop around 2 things. First, we're going to steal a little bit of the most recent slides that Hongfeng Yu, the director of the Holland Computing Center, put up recently. And then the other thing that we're going to do is we're going to go through a slightly older version of kind of what I would describe as an explainer for how the cluster that we primarily use is Crane. You have access to all of them, but if you use Crane, you should never have conflicts. You'll have pretty much as many compute resources as you want. And it works great. It's awesome. So with that out of the way, can you see my screen? Okay, so one other thing I should say before I get started is simply that our HCC user group would never have been possible if it were not for the founding director, David Swanson. Dave was a really remarkable person, and if you're someone who appreciates the work that others did to make what you have possible, go read about him. I am pretty sure that Swan, the new cluster that they have, is kind of an homage to the man. But Dave was awesome. So the origin of our user group was that Dave originally reached out to OS2G about trying to put together a competition team for what's called supercomputing, which is the world's largest supercomputing conference. And the students in the group didn't quite have the knowledge necessary to be able to compete and do well. And the intermediary step was to make it possible for motivated students who were interested in this kind of material to gain access and start working with it, so that they had the basics down before moving on to something more intense. Unfortunately, Dave was in a car accident, I believe in 2019. And so as a result of that, that team never materialized. Maybe someday one of you will, kind of kick the tires. You'll need a faculty sponsor. It is not a small thing, but at minimum, it's worth taking 15 seconds to note that all of this is possible because of Dave. So thanks, Dave. All right, with that, let's talk about all the super cool stuff that is in the computing center. HCC is huge. It has been being built up over 20 years. They provide research access to all kinds of people. There is CERN processing that gets done on this thing. I mean, you can see right here some of the statistics about it. The more time you spend on it, they've got a bunch of different demo cases that they talk about, and we're just going to gloss right over them. But people have done some really crazy things using the Holland supercomputer. So like you see right there, the big one is 7 million CPU hours each month. That's what people use. That's not what's possible. There are almost 37,000 compute cores, 23 petabytes of storage, and it's part of internet too. So the connection is 100 gigabits per second, and it's under a millisecond latency. There are also 132 or 134 GPUs, including NVIDIA V100s, and most recently, I believe the T4s. So there are some really beefy, awesome resources that are here. And there are a number of people with the HCC who, if you decide you want to do something crazy, often they'll give you the time of day if you just go talk to them. And I cannot recommend them more highly. I cannot sing their praises well enough. They're great. So in the event that you're ever trying to do something new, reach out. They even sometimes have student jobs that are a lot of fun. So get in touch with them. There are 3 main facilities. There are 2 here at UNL and 1 up at PKI. The statistics are here, but they're huge. And if you're very, very lucky and you're very, very nice, and maybe you guys could even try to get a club tour if you ask them nicely enough, they'll take you down into the basement of Shore Center, which is just on the south end of the stadium, and you can see the massive bank of servers. There's even one that's got a Huskers football helmet on the front of it, which is pretty cool. So let's keep going. Right. So these are where the actual clusters themselves live. So we'll go over some of the big ones really quickly. So the main one, and the one that we're going over today, is Crane. Crane is massive. It's got 52 V100 GPUs, commonly sitting empty. So you can do all kinds of terrible things with them. Within reason, if you try to mine Bitcoin, you will get kicked off. So please plan accordingly. 11,000 compute cores. Red is even bigger. We generally don't use Red because that's funded by grants. The other really cool cluster that if you're lucky you can get access to is called Anvil. Anvil's awesome because it's an OpenStack cloud machine, and what that means in normal people language is it's a giant VM spawning box. So if you wanted to try and run something really crazy that you've never tried before, provided the hardware support is reasonable, you can just spin them up and do whatever and knock them down, and that's it. And it's very, very cool. Attic is the main storage system. There are nearly 3 petabytes of storage just in Attic. And they're in the process. Currently, what the center is working on is improving and upgrading the storage configuration and setup for the cluster properly. So those are all the new ones. This is them talking about the updates that they're doing, which is great. If you want to get involved or interested in that, you can ping them. The big thing that they do, again, is they provide education. There are a ton of really great resources. HCC's documentation is, it's a rabbit hole. You can spend as much time reading as you want. You'll learn all kinds of crazy things. And there also are partnerships that they have with other compute centers. So if you're trying to do something crazy, which most undergrads aren't, but if you wanted to, it's there. So file that away. There are a ton of different people doing all kinds of everything under the sun that you've ever heard of. There's biological work being done. There's social science being run. There are people just compiling huge piles of code on it. So this is kind of a distribution of some of the different stuff that they're running. BLAST is a gene sequencing. If memory serves, the Center for Bioinformatics is the single largest user of HCC. Jean-Jacques is a very, very cool, nice person and incredibly intelligent. But even stuff like Python runs phenomenally well. And in fact, a lot of the improvements that we've seen to the Python language have been the result of people running it in a supercomputing setting. So like I said, tons of different, you name it, somebody's tried to do it. Here, let me reduce this so that it's not taking as much up as the screen. So here's an example on healthcare. Here's another one on social media analysis. Another one on RNA nanostructures, which this one I believe Caleb worked on. I might be wrong about that, but I'm pretty sure that's right. High throughput phenotyping of plants. Even stuff involving art. So machine learning and AI for art, which is exactly what we were talking about with stable diffusion. On demand is cool. This is worth taking half a second to discuss. Basically, it's I would describe it as a simplified GUI that makes it so. For example, if you've ever heard of Jupyter notebooks, on demand makes it possible to use them and run them, which is incredibly helpful. And it's also easy. And it's kind of, what's the phrase? Shall we call it turnkey? By which what I mean is you can just kind of sort of pull it up and start something and run it, and all the configuration stuff we're going to go over today, you can ignore its existence and just run code. So you can use a supercomputer without needing necessarily the knowledge that we're going to go over today. But there are different times where you'd want to do both. So exactly, these are some screenshots of on-demand working. So for example, if you need to do visualization, a lot of visualization stuff in a shell can kind of suck. It's not easy. And so on-demand is really convenient for things like that. Like I said, Jupyter notebooks, or anybody who's interested in Kaggle and data science and blah, 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 this is your spot. So Anvil, we just talked about that earlier. The storage is wild. Predominantly, you are going to want to use the work directory. We'll show you some of that, but you can just use home if you want to be, shall we call it, quick and dirty. That'll be the way that we put it. File transfers, this is what we're talking about. Globus Connect is how, if you want to upload large files onto the supercomputer, that's how you use it. Globus is, we'll say, kind of unpleasant, but it works, and it's made to ensure that your files are not full of naughty things. So, but then of course you can just upload them as a zip file, and so with a grain of salt. It is very useful, and if you are trying to upload large data sets that you're not directly downloading from somewhere on the internet, you're going to need to know how to use Globus. But it's very simple to set up, at least if you're on Windows, and it can be done on Linux without too much work. So that's what the GUI looks like. Again, lots of different ways you can access and get at these people if you want their help. So with that, we're gonna go ahead and stop sharing this presentation, assuming the computer doesn't crash, and move over to the other one that talks about Crane itself. Are there any questions?
Just where I come in.
That didn't sound like English. Any questions
Where
from
I come in, or is this?
Give me a second. I got to tell people here's how you get on Crane, and don't run. The only reason we're showing the next slides is because if you run a compute job on what's called the head node, we'll explain this concept in about 5 minutes. But if you run compute jobs on a head node, they will kick you off and they may get
the login node.
Yes, exactly. So don't do that.
I mean, it would suck running it on that anyway, but we won't get into that.
Yep. So any questions? I'm looking at the room. Nobody's raising their hand. Nobody's looking around. Okay. Yeah, normally I'd live on audience feedback, but I can't do that because I'm here on the internet. So let's just do a quick and dirty screen share really fast. These I only have as PDFs because the original slides which were posted have since been taken down because the world moves on. Okay, so like I said, big 4 steps. If you want to use a supercomputer are 1, you got to log in. 2, you got to know how to move around the files. 3, you got to know how to get the software you want loaded. And 4, you got to know how to actually run the jobs. So we'll show you how to do all that. This is just meant to be a 5-minute overview of how that works. So we don't care about that. We don't care about that. Okay, does everyone know how to use PuTTY? Let's ask that. Actually, we'll assume that people don't. If you don't know how to use PuTTY, all that it is, it's a free tool that you can download. You can also use Terminal through Mac. There are plenty. The SSH clients are a dime a dozen. So
I know PowerShell has SSH now. You don't need.
Yep, exactly. So all you need to do, you just need the ability to remotely connect to a machine and log into it, and that's it. You do that, you're good. So let's talk about what a cluster is. So the way that a cluster works is you've got a storage array somewhere where all the data lives. You've got a management node whose job is to oversee what is going on. You've got a login node, which is what people originally connect to, and then you've got worker nodes, which actually do all the compute itself. So the big task is to log in to the login node, to then allocate a job to the scheduler, which runs on the management node, which then runs the compute task on the worker nodes, and then the results come back and are given to the login node. That's it. It's not complicated. Setting it up is a little tricky. So there are 3 different clusters. I believe this is now 4. So the one that we care about on the top right again, Crane. There are 16 to 36 cores per node. That's a lot of CPU cores. You are not going to need that many. 64 to 512 gigabytes of RAM per node. Also a lot of RAM. So one of the things you could theoretically do is run hashcat on a supercomputer and try to see if you could crack a simple password. That'd be a fun exercise that I totally haven't done. Okay, Anvil, again, pretty cool. Attic, also cool. So to connect to the cluster, you SSH on. Once you have SSH'd on, and here's how you do that. These slides, by the way, are on the Git repo. That is os2g, or sorry, github.com/os2g/hcc demo, all lowercase. So if you want to go through this and follow along on your own, it's all available for your access. So you can SSH via command line, or you can just use PuTTY. PuTTY's great, highly recommend, does a ton of stuff, really useful. But the domain you're going to want is, in this case, it's crane.unl.edu, port 22. When you open, you will be prompted for your username and password, which most of you don't have yet, but you can get in about a week, we'll say. Then there's the 2-factor authentication. You set that up, away you go. With these 4 bash commands, you can successfully move around the file system. So ls lets you see which files are there. CD lets you change into a directory. Nano lets you edit files. And less lets you read a file. You can also use more, it doesn't matter. If you are not familiar with bash commands yet, OS2G has some great resources on it. Shout out to you guys for all that jazz. But there are plenty of online resources that you can go through. But if you know these very, very dirt simple commands, you're good. There is also a HCC resources page on the main OS2G website that has links to the software carpentry tutorials that are made specifically for use with a supercomputer. So if you want to learn Git in the context of a supercomputer, which it really, there's no difference, but if you want that, it's there. Okay, then you disconnect. And with that, the question is how you actually create files. So there are 2 main directories. There's your home directory and your work directory. You can see how those are tied in from the actual root itself. Home is not intended for input output to active jobs. You can use it that way, but it won't run as fast. Work is made to. You will have access to both. Transferring files between them is relatively straightforward. This is only going to be an issue if you're really dealing with large files. That said, yep. So the licenses thing sometimes matters, but generally it doesn't. Those are all the difference of files. Yep, these are some good best practices. Don't use a large number of files because it will degrade the performance of the file system. You do have limits. Use Globus to upload stuff and back up things that you really care about. But since most students are just tinkering, it doesn't matter. SCP is going to be the most common way to transfer files. The other way is Globus Connect. Or if you're using something that's regularly available on the internet, you can just wget it onto the directory where you want it. So this is a walkthrough of how to actually create a file. We're going to skip this for the time being, but it's worth going through on your own. Loading modules. It's as simple as module load the module you're looking for. Module avail will list all the modules. I don't recommend it. Easiest way to figure out which module you're loading is to look at the HCC documentation. What modules are, basically it's a bunch of prepackaged software. So Python, the GCC compiler, R, MATLAB, whatever, almost everything you'd ever want is up there. And if the specific version of a specific software that you do want is not up there, you can just email the admins and 90% of the time they can get it loaded, though you might have to do some work to configure it or to have them fix it. So there are core modules which don't have any dependencies, and then there are other modules which do have dependencies, and that gets complicated. So with that, there is a scheduler. The scheduler for the supercomputer is called Slurm. It is named after Futurama's Slurm. So if you like that funky green soda, which is totally not Coca-Cola, this will make you laugh. Slurm is awesome. Slurm is really useful. Slurm does have its own weird syntax, and we'll get into that when we show you how to do it. But the long and short of it is you use the Slurm scheduler to run jobs. There are two different kinds of jobs, interactive versus batch. We'll get into some of that later. Oh, that's important. If a job exceeds the requested memory or time, it will be killed. So if you wrote something kind of goofy, it is possible that it may just die and you won't see why, unless you're smart about how you add the logs. There's a bunch of different commands. There's also a Slurm cheat sheet, which I believe is linked in the HCC resources. Highly recommend it because I forget all this stuff. And with that, I think we are through. This is what the submit script looks like. We'll go through one of these in detail here in a second, but there's the file name. There's the different options that are done. And then here are the actual commands that run the job. So, and those are like you're running a normal command on a Linux box. So when you're trying to choose your parameters, there's a ton of different ways you can do it. The short answer is experiment. Unless you're doing something really crazy and intense, most of the stuff you can't really do anything wrong, so you're going to be okay. So don't sweat this at the beginning. But if you do start getting into more intensive stuff, like trying to do high frequency stock trading analysis or training a massive, neural network, you might want to pay attention to some of these details. There are some best practices, but that'll only matter once you get into it. With that, we are at 8 minutes, so I ran a little bit longer than I wanted, but this should be everything that you need. Okay, Alex, are you ready?
I have been, of course.
Good. Let me take 5 seconds. Were there any questions on some of that stuff? Because I blitzed through that. This looks like silence. Okay. One other thing I would say, the walkthrough that we're about to show you, I'll dump a link. Honestly, I can just show it to you, or I'll tell you about it. Google Colab is Google's free HPC resource. It's awesome. There's a Jupyter notebook for everything you've never tried. It is nowhere near the kind of compute resources that HCC offers, but if you want something that's just a thing you could do on a Tuesday for 20 minutes to try it out, I highly recommend Colab as a starting place, and everything we're about to cover from here does apply. So, okay, with that, I'm gonna mute myself, and good luck, Alex.
All right, hey guys, can you hear me?
Yep.
Beautiful. Okay, so let me actually screen share. We're just going to walk through logging in, how it feels, what is the mouth feel. So that's what's going to happen. Let me make sure I'm on the right terminal when I screen share. Actually, I'm just going to screen share my screen. So if you want to log in through the command line, this is what you're going to want to do. Your username. Now, if it was Crane, you just do this, then .unl.edu, or it could be Swan or, Red or whatnot. So now we need to talk about, as long as I type this in correctly. Oh, give me a second. There we go. So you have 3 ways of getting this authenticated, and it's all through Duo, which I think Mitchell has already mentioned to you guys. So for me, what I have to do, I just do the passcode option. So I just do a 3 that texts me a series of passcodes that I can then type in from. Boom. Now, now let's also talk about this. This is just HCC do, and it talks about how much of each quota you've filled up. As you see, for me, so this is the weird thing that I think Mitchell might have already brought up to you guys. You have an individual 20 gigabyte capacity on the home section, but if you taxi over to the work thing, we all share the same capacity. 50 terabytes, 50 terabytes from the user and the group. So with home, it's just, you don't have to worry about how the space you're taking up affects everyone else. With us, you do. But as you see, we're nowhere near the limit, but just, I don't know, be cool. Don't make it a nightmare by suddenly dumping like 20 terabytes of media file server stuff and who knows what. Don't do that. So also, the reason why, so let me actually just show you guys. So your $ work, that shows the folder for this and for column. Now you can see it's pretty simple. /work, your group, then you. So that's just kind of how you're taxing around. Now, as you see here, I have a lot of crap. And actually, I'm gonna look at the files I have that are eligible to be purged. It turns out it's a lot. I love that. I love that for me. So I probably need to make sure they don't, because this is a kind of a bad thing. I'm one of those people who has everything on their work directory, which means it's all eligible to be purged, which don't do me. Have backups, because the thing is, work periodically they don't really seem to purge aggressively, but work does have disk crashes probably every 6 to 12 months. And then you're just kind of clenching yourself, hoping that, all your files are not lost forever. So don't be me. Now, I'm just going to actually remove all of these. So here's our tutorial code that we have right here. And actually, yeah, I think I will remove in this while it's here. All right. So, and I'm going to let's actually talk about the Slurm commands, actually, while we're here. So he went over a few of them. This will show you a list of the current or recent jobs you've ran. Now, the weird thing is that you'll have, for each job you submit, if it's through a batch, you'll have 3 lines. But as a general rule, it's not really a big deal. It's just the same job. Now, this command, you will want to swear by this command, especially if you're like me, you're doing machine learning, because what Mitchell didn't talk about, when you're submitting jobs, you submit them to a partition, and in turn, you make requests from that partition. So I'll just show a very simple, actually, yeah, we'll first talk about how interactively that would work. And then, and yeah, and then we'll talk about how you submit it through a batch. So this thing will actually plop you in a shell with the resources you request. And I'll explain everything in literally a hot second. PTY. So here's how this works. We only want one node because we can only be running interactively on one node anyway. If you want to get more than one node, we're just not going to get into that. Just assume, because it basically would mean you actually be running stuff simultaneously on multiple machines, which does not work automatically, and it's a lot of work. So we're not going to touch on that. Number of tasks per node. This is the number of cores you get. On the GPU partitions, you can go up to 47 to 48. Memory. You can ask for up to, on the GPU nodes, you can ask for up to like 200 or so. Now, this just says I want a GPU. Now, if you want to have it be specifically like one of their V100s, for example, it kind of, because by default, they'll give you the most powerful GPU they have available at that moment. But if they don't have that one, but more the most powerful one they have at that moment, well, you get down to the lesser one. As you see here, it is very quiet. So we're going to get the V100 when we do this. Oh, yeah. I don't know how to type. So this should happen almost immediately because there's no other competition for these nodes. So there we go. Boom. So I'm not actually going to run anything while we're actually, no, I take it back. I will. So first thing, if you're doing machine learning stuff like I am, query NVIDIA Semi. This lets you see the current GPU you got. And in this case, we got the V100. Now, so again, this is going to be very machine learning biased, I guess. We're not going to be talking about how you do genetic analysis or any of that cool stuff Mitchell's talking about, because personally, that's what I use supercomputers for, is to train stuff. For that, you need the GPUs. So we get a 32 gigabyte video memory one, and bear in mind, this isn't even the most powerful one they have now. It's now on Swan. They have these things called, I think, the P4s Mitchell was telling me about. So bear in mind, this isn't even the most powerful one they have right now. And it is exclusive access for you, which is, in my opinion, pretty cool. So what I have here for a little cute demo for us is just running a basic neural network with, 512 layers, 3 different times, then outputs out to this, 10 here, and it classifies MNIST. And if you don't know what MNIST is, I'll take you on just a quick magical journey just so you know what MNIST is. It's a digit classification database that just is like this. 28 by 28 pixel images, and it's one of these digits, and you have to try to figure out if you classify them as such. So let's go back. So 28 by 28 pixels. Because yeah, I'm not going to get too much into that. I don't want it to be too much of a distraction. But anyway, we just do a standard PyTorch train and test loop. This is basically verbatim tutorial code from their website, so I won't dwell on it too much. But in any case, we have this batch size. So, and actually, what I'm going to do, I'm going to have this thing start from scratch, because I was actually having it basically load from its last save point. So I'm not going to do that. So, in any case, what we then do, so I'm going to show you, this is something called LMOD, which is this module system they've had for a long time, which lets you more or less automatically load programs in that they already have. For me, in this case, it's their GPU PyTorch thing. They have something fancy now called Singularity, which is basically a cooler Docker, but I'm not going to touch on that. So anyway, once you've done that, then you should be able to just do this. So it's downloading MNIST, and now it's running. So anyway, as you see, it's training, doing its own thing, yada, yada, yada. So this is how this would be working interactively. The big catch though, you have to have this shell open now at all times. If I just dropped this shell connection, this job would immediately die, which obviously that's a big problem. And this is why you almost never want to do anything interactively. And if you do, you would want to do it indirectly by on demand, but we're not gonna get into that either. So we're gonna exit. This will relinquish our lease on that node. So now if we go into S account again, Slurm account, you will see we had it running through bash and it's completed.
Stops.
Connor, what's going on?
Connor, this is your fault.
Oh, they're just saying that I'm on mute.
What?
What is
Not to you,
happening?
Denny.
I can see you guys, and then Connor speaks up, and suddenly you guys, I can't see you guys. There we go. Anyway, Connor, did you have a question?
Oh no, I did not. Sorry.
Oh,
Never mind, I found socks.
What?
I found socks. Do you want to call?
Yeah.
Oh, I'm sorry.
we good?
Alex, I think you're good. We can edit that out later.
We can edit it out. Don't worry. We can edit this out in post production. Anyway, so obviously you never really want to do that, interactively. So what you'll like to probably do instead is run something called a serve script. What this lets you do is basically submit a request. It runs your commands, and then you can log out, and it'll just go as long as it wants. So you give it a name. Actually, you probably didn't need this line. Don't worry about this line. This is the one that says the cores. I know that's kind of confusing. The nodes is the same as before. We're on one node. We're not gonna basically we're only on one machine, and we get 16 cores from that machine. 64 gigabytes of RAM, same as before. We have a 2-hour time limit. So if their program has not finished, this program that's run here, if it has not finished within 2 hours, you will be given like 30 seconds to spin down, and then you'll be force killed. So keep that in mind. We request the GPU partition, which is where all the GPUs live, but as you probably already know, it's actually implicit from the fact we do this. So this line here isn't exactly necessary, but and I explicitly request the D100 with this constraint, but it's not necessary because we're just doing MNIST. Then I also specify all standard out goes here. This is the job. This is the job number, and this is the if I remember correctly, the name we put up here. So output demo number, as you can see right there. Then just print out some stuff here, which goes straight to this file, and then we do srun. So, and then everything that happens after srun is your command you're going to invoke. So for my case, I invoke this launch script bash, which then runs on this node here, and we'll have access to spinning up to 16 threads. Now, let's go to that script, which is pretty simple. Hey, load that module. Hey, run Python 3. So when you do that, let's see how long it takes for us to get reserved. So it's still pending. Now it's running. So as you see, I already created this. And if we go here, let's see, there we go. It's already running. So yeah. And at this point, this will run more or less on its own for as long as we want. And you can log out of, this is the login head node that Mitchell's saying never run anything intensive on this. Because, well, so anyway, you can log out of this already now and leave this job running. But in any case, never run any serious program on the login node. Never, ever, ever, ever. If you're doing any real work, you immediately get off the login node and you make an interactive reservation. Because the login node, fun fact, that's shared by everybody when everyone logs in at first. So when you do that, if you accidentally clog up login node, that means that people can't log in.
So
This is why Mitchell was saying they will kick you out, because they'll be like, hey, why can't anyone log in right now? Oh, Papa Palpy has some errant job that they're running on the login node. Okay, kill his session.
My favorite metaphor for this is like it would be as though you went to a restaurant and then you tried to eat at the maitre d's booth or the hostess's booth at the entrance of the restaurant. So
Yeah.
everyone else who wants to enter the restaurant can't get to their stuff because you have put plates over the reserving table. So
Yeah.
then, of
So-
course, we'll take you and throw you out.
So yeah, if you're just an idiot a few times, they will just be annoyed and kill your process and boot you off of your login. But if it happens habitually, you'll probably start getting some very angry emails, and that causes problems not just for you but for everyone else. So don't do that, pretty please. Because they do accept that people just make stupid mistakes, and that's okay. Just, you know, do not make that a habit. So, any case, and the big thing you like to do. So SQ, along with selecting a partition input. So SQ just by itself, it will list off every job that is running on the entire supercomputer at any time. And you can set filters for what you want to look for. Batch is the generic partition. That most people run all their stuff. Like that's where the in-blast, all that stuff is. As you can see here, here's Anvil. Where is GPU? It'd be somewhere, but there's only 3 of these jobs. So A, B, C, D. Oh yeah, yeah. Here's GPU. It's right here. I also forget to mention, if you're wanting to run on the GPU, there's also a guest GPU partition, which kind of overlaps with the GPU partition. You get quicker access. But the issue is that if it's basically consists of reserved GPUs that are not being used right now. So if anyone who actually does have those reserved logs in and wants to use them, you get immediately preempted and kicked out, which doesn't happen with the GPU one. So only use this one if you're desperate. We're doing machine learning stuff. Otherwise, batches, if you're doing that cool computational analysis stuff on like gene editing and all that, that's where all the stuff runs. Or physics calculations, all that stuff. That's where all that stuff runs generally. Also, okay. If you are waiting, you see on this node list or a reason, it will tell you if you don't have a reservation right now, it will tell you why you are not able to get reserved right now and why you're in the wait list. There are 2 ones. Oh, 3 ones. One of them is the maintenance one, and that's where you're the thing you're requesting is down for maintenance, so you're gonna have to wait. The second one is resources. That is if there's too many people using it right now, you just have to wait. The third one, which is probably one most you might want to pay attention to, is priority. If you've been submitting too many jobs, your priority goes down, and even if you've been waiting longer than someone else for a reservation, they will prioritize that person over you because you already have 10 or so jobs running. So this user right here, Jan, since he submitted a gajillion, say with a Hooper, they have all been deprioritized in favor of other people for their, because they've already been submitting a bajillion. So keep that in mind. And since there's like 50 of those V100s, only having like 4 people here basically means anyone can be using this right now. Things have been quieter ever since Swan became a thing. Now most people are fighting over, the Swan's resources. Now Crane's like, it used to be a lot more crowded here, but if you're wanting to do some machine learning work, no one seems to be using this anymore. And the V100s are insane. And I'm not going to get into it, but you can like chain them together by having more than 1 node at a time, which is kind of insane. But that is outside the scope of our discussion today. All right. Well, yeah, this is pretty much it. Let's see how that end this thing's gone. Oh, look at that, 95% accuracy. So, oh, and we're going for epochs like crazy. Because this consists of like, I think hundreds of thousands of digits. So yeah, that's all I have for you guys. I know this is probably a bit of a fire hose of information, but what you need to know is that if you're doing really insane computational analysis of any kind, machine learning, weather analysis, gene stuff, bioinformatics, blah, 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 anything where it's like my laptop isn't going to be able to cut this, and it's not like playing video games, this is the place to be. And HTC is very unique and special. I just got off like just a few days ago. I got off a call with this kid from Berkeley, and he was complaining that for like undergrads, it's almost impossible to get any sort of supercomputer resources for anything because they have so much red tape around this stuff. Nebraska is almost unique and special in the sense that you can get insane computational resources with almost no red tape. This is not something to be taken for granted. They are incredibly lax and kind to us in our group. So this is a type of goodwill that we really want to keep going, because what we have here in Nebraska is really special. And none of you guys should take that for granted ever. This is really genuinely one of the ways how UNL is one of the best in the country for doing this sort of thing. So enjoy it.
With that,
A lot of times we get to say as UNL, we're number one. This is one of those.
So a statistic that I personally love and I'm really proud of as an alumni is UNL is one of 2 universities in the Big Ten where any undergrad who wants to learn how to use a supercomputer can gain both education and access to compute resources to do so. We're only 1 or 2. I think the other one is like University of Michigan, which makes sense because they were one of the very first circa 1970. So it's pretty cool. I think, are there any other questions? Because that was a lot of material there, or was there anything that was unclear from the audience?
Yes, how do we make an account?
Back to square one. So I will go ahead and I will dump the link both on Discord, and I'm actively updating the README as we speak. The short answer is you go to HCC's website, and it is one of the first. They've got a little tab that is new users, and it's just new-user-request. There is also a description of this process that lives on our that lives on the OS2G website. So that is the request form that I've just dumped on the OS2G Discord. I will also add it to the GitHub demo repo really fast. And then the actual, so OS2G, unl.edu/HCC, there should be a lovely little explainer of most of this stuff. Here's the actual OS2G resources page, and there are a ton. Once you get started with the basics, there's all kinds of magical fun things that you can go and try to do with very little work, and there's a boatload of resources. There's another thing I should tell you guys about that's called XSEDE, XSEDE. It's the Supercomputing Center at, I want to say, the University of Pittsburgh. And they are as big and bad as this educational stuff gets. There are also a ton of free workshops that I regularly get emails about that I can start forwarding to the mailing list if anyone is interested. Where if you want to learn how to do computational physics modeling or whatever, people run talks on this kind of stuff, and they actively are looking for bodies in the seats. So if you want to do this kind of stuff, I wouldn't say the sky is your limit, but it's pretty close. So does that answer your question?
Yes.
Perfect. With that, I think we're done with the recording. Do you guys mind turning that off?
One quick question. Do you want to go through that sign up form just in case?
Yeah, sure. You know what? That's great. Thank you,
Also,
Tim.
hey, I think I actually need to get going. Is that cool?
Yeah, that's great, Alex. Thank you for your help today.
Thank you. Bye.
Bye, Bill.
Bye, Bill.
Alex.
Bye.
Okay, that falls on me. I can do this. I believe in myself. Where's that sweet, sweet request form? I just had a link and Google's not going to help me. That's okay. I can get there in 2 clicks. Yeah, so to request an account, I'm going to disable my shields for the time being so that it'll run correctly. Let's refresh that. And now all the pretty CSS, oh, it still looks ugly. All right, that's fine. I guess that's a dark mode problem. So let's share my screen. Can you see it?
Yes.
Cool. All right. So all you got to do is request an account. Watch this. This is pretty difficult. Select your group. We are CSE OS2G. We wanted OS2G, but it had to be 6 letters and it's still funny. You put in a username, so we can do test account and we'll do submit and it's going to complain at me. Actually, no, it just took me to the next one. So then I fill in all my information. I'm not going to bother doing this because duh. But this is where you punch in, your name, your NUID, a phone number, so that if you're doing something naughty, they can call you, which campus you're on. If you're part of the University of Nebraska, you can still join through this group. So even UNL students could probably do this. Most people here would probably qualify as an undergraduate student. So if you make your life easy, you can use your Huskers at UNL.edu. They want to know what college and department you are because they actively care about these statistics. You can get an account, any UNL student. I don't care what you study. If you want to use it, you can do this, which is that we're the only ones, which is cool. And then generally it asks you, this is the one that most students get scared by. It says, briefly describe your research in general terms. Your research very well may constitute, I want to learn how to do the bare basics. Let's say, teach myself how to use a basic supercomputing. This is perfectly valid. As long as your answer isn't, I want to see how fast I can mine Bitcoin, they don't care. The goal is to let people learn and experiment, right? And provided you're running experiments that add value to someone, even if it's to yourself necessarily, they'll probably be okay with it because it shows that people use these compute resources. Students use these compute resources as an educational tool. And that is an incredibly beneficial thing for HCC. So if you consider doing this and you're like, you know what, why not? Try it. Even if you wind up not liking it or deciding that you don't want to use it, or you just pick up another project that's more shiny and fun. That's totally fine. But yeah, so this is the one field that most people are scared about because they don't have an immediate answer. You certify that you are not putting classified or people's medical data on it because they don't do that. You classify or you agree that you have read their policies, which means don't be a jerk. Don't do terrible things with this. Don't run jobs on the head node. Cool. And you check this box if this is an account for a class. So we are not. Don't click this one. If you do this at the end of every semester, it gets deleted. So even if you are in a class that uses the supercomputer, there's a pretty good likelihood that you'll actually want to be a part of, because once you start, a lot of the 400 levels actively do use, they have their own supercomputing groups. So maybe I can show, I'll go back to the previous page and show you that. Yeah, but so at the end of the course, the content gets deleted because you don't need it anymore. So we're not going to qualify. And then you just click submit request. And on the next page, it'll have you finalize it. I'm not going to have it finalize anything because I don't want to spam their system, but that's it. And then you're done. And it's that simple. You can fill it out in 5 minutes. And like I said, it'll probably take about, maybe 3 days for them to go through and read all of it and confirm that you're an actual student. And then they'll send you an email and have you just come down and show some kind of actual real ID, your NUID or whatever, to confirm that, yes, you are who you claim you are, and you are actually a part of the university. And they set up your Duo auth, and that's it. And you're done. So, Gabe, you had a question?
Mitch, I don't think they do the in-person confirmation of ID.
Oh, really? Oh, they might have updated that. There's a very good likelihood that they now do it via the internet because COVID totally happened. So part of why it used to be in person was so that you would come down and say hello. And by saying hello to them, you would get to know them. And if you had any questions, you knew who to ask. It was about establishing community. But that said, COVID did change a lot of that and make it virtual. So Gabe, you're probably correct. Do you know what they do now?
Yeah, well, it could have changed. I got my account last year. When I did it, they gave me an email with the Duo instructions. And I think I emailed someone my NUID, and then they sent me a little PDF that said, here's how you sign up for the Duo account. And like sits right alongside my other Duo accounts. I get pinged the same way. I can just go pay them on my phone.
That sounds pretty simple. Cool. Cool. Well, so even better. You don't even have to leave your house. You just have to wait for them to email you back, and then you fill out another form and you're done. So that's even easier than I remember. And if anyone ever does have questions about usage or things that you're trying to do, part of the things that we try to provide, or at least that I hope to provide, and I still will do this through the Discord. If you ever have questions about how to run things, there are people who are rather knowledgeable about this stuff who, shall we say, lurk, and they're happy to answer questions. So if you don't know how to do something, or you're having problems running something, or something is running weird, use OS2G as a user group to talk to other people and see if anyone else has had your problem before you. So I'm done. Anything else? Tim, thank you for pointing that out. That's something that I should have done. So I appreciate you. Okay. I have felt awkward being recorded for long enough. So Luke, if you would do the honors, that would be lovely.